NASA observatories have detected something that makes asteroids look like child's toys. A cosmic force so violent it could vaporize entire continents in seconds, leaving our planet as barren as Mars. We're talking about gamma-ray bursts, the most powerful explosions in the known universe. Right now, as you watch this video, beams of gamma radiation are traveling through space at nearly the speed of light. Some of these beams carry enough energy to destroy all life on our planet, turning Earth into a dead rock floating in the cosmic void. To understand the magnitude of this threat, we need to delve into the extreme physics behind gamma-ray bursts. These explosions arise from the violent death of massive stars, when they collapse to form black holes. During this cataclysmic process, jets of energy are fired from the poles of the dying star, creating beams of concentrated gamma radiation. The energy released in just 10 seconds of a gamma-ray burst is equivalent to the energy our sun will produce over its entire 10 billion-year existence. To put this in perspective, imagine all the solar energy of the last 4.5 billion years released at once, directed like a deadly beacon across the cosmos. Researchers recently identified GRB 250702b, an event that defies our understanding of physics, lasting an incredible 24 hours when most gamma-ray bursts last only seconds. This discovery rewrote the textbooks on what we thought we knew about these cosmic explosions, showing that the universe still holds terrifying secrets. Space telescopes record these events almost daily, scattered randomly throughout the universe. Each detection represents the violent death of a star in some distant galaxy, but it also serves as a grim reminder of what could happen if one of these events occurred too close to home. The mechanics behind these explosions are terrifying in their simplicity. When a star with more than 20 solar masses exhausts its nuclear fuel, it collapses under its own gravity in a matter of seconds. The star's core is compressed into a black hole, while the outer layers are ejected at relativistic speeds. During this collapse, intense magnetic fields channel some of the energy into collimated jets that traverse the stellar poles. These jets, traveling at over 99% of the speed of light, carry concentrated gamma radiation capable of traversing entire galaxies, while maintaining their destructive power. If a gamma-ray burst occurred within 200 light-years of Earth and its deadly jets were aimed directly at us, our planet would be completely vaporized. The atmosphere would be stripped away in seconds, the oceans would boil instantly, and the Earth's crust would be melted by the intense radiation. Even at greater distances, the effects would be catastrophic. Scientists from NASA and the University of Kansas have calculated that gamma radiation from a relatively close stellar explosion, hitting Earth for just 10 seconds, could deplete up to half of the atmosphere's protective ozone layer. Recovery would take at least 5 years, enough time to completely devastate Earth's biosphere. The destruction of the ozone layer would be just the first act of this cosmic tragedy. With atmospheric protection compromised, deadly ultraviolet radiation from the sun would bombard the Earth's surface unhindered. Plants, the base of the entire food chain, would be the first victims, unable to photosynthesize under intense UV radiation. Ground-level ozone would form when UV rays penetrate the planet's surface, breaking down oxygen molecules. This tropospheric ozone, unlike the protective stratospheric layer, is a toxic pollutant that would cause severe respiratory problems in the initial survivors. The oceans, by directly absorbing gamma radiation, would experience a massive die-off of phytoplankton. These microscopic organisms produce more than half of the oxygen we breathe and form the base of the marine food chain. Their extinction would result in the total collapse of ocean ecosystems, eliminating a crucial food source for billions of people. The Earth's food chain would collapse in a cascade. Insects essential for pollination would die en masse under unprotected UV radiation. Without pollinators, flowering plants would be unable to reproduce, accelerating the collapse of global agriculture. Wild animals, losing food sources and suffering from radiation-induced skin cancer, would face mass extinction. Even human survivors in underground bunkers would face impossible challenges. With the atmosphere compromised, radioactive dust storms would sweep across entire continents. Global temperatures would drop dramatically due to atmospheric dust and debris, triggering a nuclear winter that would last decades. The threat of gamma-ray bursts is not merely theoretical. The late Ordovician mass extinction has been hypothesized by some researchers to be the result of such a gamma-ray burst. This extinction, which occurred approximately 450 million years ago, eliminated 85% of all marine species at the time. Geological evidence suggests something extraordinary happened during this period. Sedimentary layers from the time show anomalous chemical composition, consistent with massive ozone depletion. Fossils indicate sudden death of organisms that depended on well-lit shallow waters, exactly what we would expect if deadly UV radiation had penetrated previously protected oceans. A massive gamma-ray burst, detected by ESA's Integral Space Telescope, has struck Earth, causing significant disruption to our planet's ionosphere. This recent event, originating from an exploding star nearly 2 billion light-years away, demonstrated that even extremely distant explosions can affect our planet. NASA has developed sophisticated atmospheric models to simulate the effects of gamma-ray bursts on Earth. These simulations, originally designed to study the effects of solar storms, revealed terrifying scenarios when applied to nearby gamma-ray bursts. In October 2022, a pulse of intense radiation swept through the solar system, so exceptional that astronomers quickly dubbed it BOAT, the brightest gamma-ray burst ever. This event, occurring 2 billion light-years away, was detected by multiple space observatories and provided valuable data on how our atmosphere responds to gamma radiation. Researchers at Washburn University specifically studied the long-term biological effects of exposure to tropospheric ozone after a gamma-ray burst. Their findings suggest that even survivors of underground bunkers would face chronic respiratory problems upon emerging into a world poisoned by toxic ozone. Analyses of Antarctic ice cores reveal anomalous nitrate peaks in certain layers, possibly indicating intense cosmic radiation events in the past. These peaks coincide with periods of minor extinction recorded in the fossil record, suggesting that distant gamma-ray bursts may have influenced Earth's evolution multiple times. There are no stars within 200 light-years of our solar system capable of producing gamma-ray bursts. That's the good news that keeps us sleeping soundly at night. The bad news is that stars move through the galaxy, and our cosmic neighborhood is constantly changing. Hubble found that Earth is safe from a class of long-duration gamma-ray bursts, but short-duration bursts, originating from collisions between neutron stars, still pose a potential threat. These collisions are unpredictable and can occur anywhere in the Milky Way with little warning. Statistically, the probability of a dangerous gamma-ray burst hitting Earth is estimated at one occurrence every 100,000 to 1 million years. This seems safe until we consider that complex life has existed on Earth for only 600 million years, and we have already experienced at least 5 major mass extinctions. Current detection systems include the Fermi Space Telescope, the Neil Gehrels Swift Observatory, and several ground-based detectors that constantly monitor the sky. These instruments can detect gamma-ray bursts as they occur, but this offers little useful warning time considering that gamma rays travel at the speed of light. Space agencies have developed protocols to quickly assess whether a detected gamma-ray burst poses a threat to Earth. Factors considered include the distance from the burst, the orientation of the relativistic jets, and the duration of the event. Unfortunately, if a dangerous burst were detected pointing toward us, there would be no time for planetary evacuation. Future projects include microsatellite constellations capable of precisely triangulating the origins of gamma-ray bursts, providing faster data on potential threats. NASA is also studying theoretical atmospheric deflection technologies, though these remain highly speculative. Underground research centers are investigating methods of preserving life in global extinction scenarios. Underground seed banks already in place to protect against terrestrial disasters could potentially preserve plant genetic diversity during a post-gamma-ray burst winter. Space exploration takes on added urgency when we consider cosmic threats like gamma-ray bursts. Self-sustaining colonies on Mars or Jupiter's moons would represent biological insurance against the total extinction of humanity, spreading our civilization beyond the reach of a single planetary catastrophe. Ironically, our best defense against gamma-ray bursts may be expansion to multiple worlds. While we cannot prevent or deflect these cosmic explosions, we can ensure that the extinction of life on Earth does not mean the total extinction of human consciousness in the universe. Computer simulations suggest that advanced technological civilizations inevitably face threats from gamma-ray bursts over geological timescales. Those that survive are presumably those that spread beyond their home planets before the local extinction event. Research continues into methods for detecting precursors to gamma-ray bursts, such as variations in the X-ray emission of massive stars nearing collapse. While promising, this research is still in its early stages, and short-duration bursts remain impossible to predict. Leave your opinion in the comments. Do you think we should invest more in space colonization considering threats like gamma-ray bursts? And don't forget to subscribe for more content about the mysteries and dangers of the cosmos. The reality is that we live in a violent galaxy, where explosions capable of sterilizing entire planets occur regularly. Our continued existence depends not only on cosmic luck, but also on our ability to become a multiplanetary species before our luck runs out. Time may be on our side for now, but the universe is vast and dangerous. Every day that passes without us expanding beyond Earth is a day closer to staking our entire civilization on a single cosmic gamble. Gamma-ray bursts remind us that we are vulnerable, but also that we have the knowledge and technology to become resilient. The next time you look up at the stars, remember, some of these distant lights may be guarding our death sentence, while others may represent our salvation as humanity's future home among the